Hello. Hello.
Hello, Toby.
Hello, we with you.
Good evening, sir.
Okay, you can hear me, right?
Yes.
Okay.
I think another group was created. I was in another group entirely.
Okay. Can you send that to my WhatsApp? I can use that to join.
No. I think we can also use this.
Okay.
Asin, are you here? I'm coming. Just give me some minutes. I'm coming.
Okay. Àwọn ọ̀dọ́ bàbá lèmi kàn tí wọ́n máa ń ṣe ti àwọn mẹ́sẹ̀gì tí wọ́n sọ lónìí mo wá rí bẹ́ẹ̀ mo wá ṣẹ̀wá síbẹ̀ mo wá rí àwọn máa ń ṣe mẹ́sẹ̀gì.
No, I left that one because
Lọ́wọ́ mo fi rí mo ní ìpè ní pé mọ́mì pé kẹ́ ẹ wá sí mítì wọn ṣe mítì bí a di o. Ẹjẹ́ àmọ̀ ọ̀tá ló ń gbà náà ìmọ̀pẹ́ ti wà bẹ́ẹ̀. Mo ní ẹjẹ́ àmọ̀ ọ̀tá ló ń gbà yẹn ní ìmọ̀pẹ́ ti wà níbẹ̀. Ṣé tí wọ́n ń ṣe yẹn. Business tips ló ti gbé wọn ìyé ilé ló sì ń pọ̀ sí wọ́n sì ń sọ́fíìsì lọ́wọ́ lé nìyẹn wọ́n ń ṣí lábùjá wọn ń ṣí gbogbo ẹbí wọ́n ń ṣí ọ́fíìsì ẹ̀sìn.
There's a background noise coming from someone. Somebody should mute their microphone on the other end, so it will not disturb your own your lectures.
yes, I'm here. Yes, I can hear you.
Can anybody hear me?
It won't call you.
Yes, I can hear you.
There are 2% daily return.
Can you see my screen? Can anybody see my screen?
Yes, I can see your screen.
So, like I said, I'm trying to introduce everyone to introduction of rib slab. So, the rib slab is a type of reinforced concrete slab in which some of the neutralities is removed and replaced with polystyrene, either polystyrene, hollow clay pots, or left as void. As what you can see in the A example, we have a rib slab that is replaced with a polystyrene, or the neutral axis is replaced by hollow clay pot, or it can even be left as void. So in doing design of rib slab, there are some consideration we need to adhere to. And some of the consideration is that the spacing of the rib have to be have the minimum of 1.5. That means the spacing of the rib should not be more than 1.5. Then another thing is the depth of the rib. The depth of the rib should not exceed 4 times the width, including the topping. So in case for example, if we have a rib of 100 mm, the depth of that beam should not exceed 400. So the other consideration for the width of the beam is the minimum width of the beam can be determined by the cover bar spacing and fire. So another consideration is for the topping. So there are two considerations for the toppings of the rib slab. Number one is when the topping is contributing to the structural strength. In this type of rib slab, we usually use these blocks, mortar blocks that we use. So the example, you can see it in this picture here. So this type of topping, the toppings are very, very small. It can be as little as 25 mm, 30 mm, or 40 mm, depending on the distance. If the distance between the ribs do not be more than 50 mm. So you can always use this you can see this in the BS code plus 3.6.1.1, table 3.17. So the other consideration is if the topping is not contributing to the structural strength. In this type of rib slab, you can leave the spacing as void, or you can use polystyrene. So those are the conditions, the consideration you consider before you design a rib slab. So one of my recent projects, when I posted some of these pictures, a lot of people are asking, engineer, what is a polystyrene? So actually, a polystyrene is actually a synthetic polymer made from monomer from styrene. So actually, what we are trying to say is that polystyrene is actually a petrochemical product. You know, this polystyrene is what we call in our local language, we call it fuke fuke. I don't know if people understand. Fuke is what we call these things. So, and when we are very small, we usually play in the sense that if you put this inside maybe inside petrol, for example, now you can see the instant reaction. So that's to tell you that polystyrene is actually a petrochemical product. So, but the hardness, the polystyrene can either be hard, solid, or plastic form, depending on the temperature. So it can be hard based on the temperature that the manufacturer decide to use. So one of the uses of polystyrene for construction purpose stands for its lightweight nature. Polystyrene is very light, so that's why we sometimes recommend it for some of our clients. Maybe they want to do an high-rise building and maybe the soil on that ground on that land is very poor. So most time we recommend or we design a roof slab with polystyrene so that it can reduce the overall weight of the building going down to the foundation. So other uses of polystyrene include they are also used in electronic and in medical industries. So now we now dive into the design proper now. And before we go into the design proper, there are some parameters we use during our modeling. So I'm going to use a topping of 75 mm. Remember that some of the consideration is that if you are using polystyrene, that's if the slab is not contributing to the structural strength, the topping should be less, that it should be between 50 mm or 75 mm. So you can see that the topping is very small, unlike our normal usual solid slab where we can go as high as 120, 150 for our solid slab. So the effective depth I'm going to use is 250 mm. Then total depth is 325 mm. The rib width is 150 mm. And the spacing, this P block means the spacing of the ribs. That's actually the size of our polystyrene. So the polystyrene standard size where the manufacturer is from is actually 3 meter by 3 meter by 600. So, but we cut it into sizes as designed. So for in this case now, our polystyrene size is going to be 250 by 50 mm. So we'll see more of this during the modeling in protastructure. So I will stop this one now. Then I will now open the modeling so we can all see how it's done.
Okay.
Now, can you see my screen? Hello?
Yes, we can. Yes, we are seeing
Yeah, we
your
can
screen.
see your screen.
Yes, you can see
Okay.
your screen, yes.
So this is actually protastructure software for people that don't know. Some of our engineering software that we use in design. So here I want to design an office block. Okay, let me show you the AutoCAD drawing. So this is actually this is the plan that we want to design. So it's an office block of 9 meters by almost 8.5 meters. So I'm particular about this open space. So those are one of the advantages of using rib slab. It can go as far as a 9 meter by 9 meter spacing. You know, when we have a length and breadth of 9 meter by 9 meter, in this kind of case, a solid slab cannot work, but a rib slab will work conveniently. So, and the floor are the same thing. You have the first floor and second floor plan. So now we go back to our design software.
Yeah.
Yeah. So because of this span is much, I have to divide it into three and put a beam. So this panel is now divided into three panels now, so that it can be convenient for the rib slab. So now remember the parameters that we have in my in my,
Okay.
in my PDF. So I'll use the same parameters for this rib slab. Our width is 150. Then our height of the beam is 325 mm. The topping of the slab is 75 mm. While the base block is
Only load the best now.
500 mm.
Just like we drop password.
So we now insert this into our model. So I've inserted the rib slab into our model. So there are still other things that we still need to do, like we need to put the strip on. It to be an FP strip.
Code in the year.
Like I said, because of time, I'm just particular about this rib slab. But the same way I put this strip, we put the same strip on the other side. But because of this open space, I'm more particular about this. So I want us to just design this open space. So the next thing is to check our analysis. Let me see if putting the actual load here. So I just want to quickly run this analysis. So the design for this rib slab is completed already. And one of the advantage of using this rib slab is that for the slab, for the top slab of the rib slab, you don't even need too much reinforcement. Maybe nominal bars like maybe wire mesh or 10 mm can be used. If you look at this beam now, they are just Y12 reinforcements. So which shows that it reduced the it's very economical in using rib slab for our buildings. But before actually we design for that, it's structural engineer, we have to work on the drawing, because it's not just that we just base and say, okay, I want to, because I've seen engineer using rib slab, then rib slab is the best. So a structural engineer will actually decide what's the best way to actually design your rib slab. So for this modeling now, the modeling is done, and we can see that the reinforcement is okay. So we have Y12 for both the ribs. So what it's trying to tell us is that, you see all this spacing here, we have the reinforcement inside our rib beams is Y12 all through, and it's a very accurate and okay. So there's no cause for alarm once the design is done and completed. So I will take you back, because of time, we don't actually have much time. So I will now take you back to our template, our template. So some of the advantage of using polystyrene is that it reduces the construction time. It's cost effective. You know, in the event of construction time, you don't even need too many. You don't need too many beams. Just the primary beams is what is very important. So unlike other solid slab where we put beams everywhere, so you don't even need too much beams for when you want to construct or design for a rib slab. So the cost effectiveness is very cost effective, because we are reducing a lot of material. You are reducing formwork, you are reducing wood, you are reducing reinforcements, and since the volume of concrete is also reduced, you are also reducing the total number of cement, the materials you are using for the granite will be reduced, the sand will be reduced. So it's very cost effective. And owing to its lightweight nature, it helps to prevent overall weight of the building. Like I said before, if you have a very poor maybe soil reports, you know, what we do is that we try to use a polystyrene so that I can reduce the overall weight of the building. So it's also good for sound and heat insulator. And other uses is that people use it for other things like interior designs now. You use polystyrene for your parapet also. Most people now use polystyrene. You know, they will just put it into the size of parapet that you needed. So I think that's all for now. So these are some of the pictures of one of our sites where we use polystyrene. So you can see the sizes. This sizes is 300 by 150 mm. So, but the length is 3 meters. But if you have a length that is more than 3 meters, you can continue with it. So, but the standard length of the polystyrene is 3 meters. But in case if your panel is more than maybe 4.5 meters, just add 1.5 meter to it. So these are some of the site pictures. You can see that we use wire mesh here. There is no much heavy reinforcement. So, and this is the casting. So I think that's all for the online webinar. I don't know if we have 1 or 2 questions that I can answer.
Yes, I have a question, Engineer Toby.
All right, sir.
So, based on what you're showing, can this be? I'm thinking this is a residential application you are showing in this picture here, right?
It's like a commercial building. It's actually a
Okay. Can you
commercial building.
can you use this in residential construction?
Yes, we can.
Okay. Then maybe you and I should discuss after your seminar, after this webinar.
Sorry, sir. So do we still have one or two questions?
So my own question is, how safe is this in terms of fire resistance?
Because of that's one of the disadvantage of the roof slab. So, but in case of fire resistance, even though if there is fire, what will happen is that the only the polystyrene will be affected. The concrete will still be in shape. So even though the building is in fire, there's not the building will not come down. The building will not have any form of maybe unless if we have maybe a very enormous effect of fire. Sure, you understand. But for the you can only have issue with the polystyrene, or the building will still stand. That doesn't mean that building will come down. But
Okay.
unlike the void, the polystyrene is only taking space. It's not as if it's a structural member. It's not a structural member.
Yeah.
So if I remove this polystyrene now, the building will still stay. Just like what I showed you here. You can see this is a voided rib slab. So this is this space, those space in between the ribs that the polystyrene is taking. So it's not a structural member. So polystyrene is not a structural member. So there's no much effect on the building.
Thank you so much.
Hello, sir. Can you hear me?
Yes, Mr. John.
So I have issues with network. Can we have the access to the recording of this webinar after the webinar? Do we have access to it?
I don't know, even I will check. I don't even know, maybe I started the recording.
I can see recording. That means it is
Okay.
recording.
All right. I will share it.
All right. Okay.
Or
Thank
you
sir.
can, I don't know, maybe if you are on our platform, on our civil land platform, maybe I will send the link there.
Okay. Which platform is that? Is it on Telegram or which one, sir?
On WhatsApp.
Okay. I
Ansi,
think I'm on the platform.
Can you share the WhatsApp group to this chat? Ansi, are you there?
Yes, sir. I'm here.
Yeah, please share the WhatsApp link to this Zoom chat group.
Okay.
Thank you, sir.
Hello, good afternoon.
Yeah, good afternoon, sir.
Yeah, I'm sorry, I didn't. Little did I know that the webinar will be today, and I'm joining just not quite long. Unfortunately, I don't know if you have treated the aspect of the services. That I want to know. Number two, you've explained that. I mean, the little I could hear from what you're saying about the reef slab. How much time can the slab, the concrete element, I mean the structural element, how much time can it withstand fire in case of any fire? How much time? Bearing in mind that the polystyrene that you're talking about is inflammable. If it catches fire, it's going to help in the burning. It's going to help in combustion.
Yeah.
All right. So how much and how long can the slab and the beam withstand fire? Two. And I don't know, have you treated services?
No, we've not treated services, but I'll discuss about it too.
All right. So those are my questions.
Okay. Let me quickly answer that. So in the event of fire, somebody has also asked in the event of fire, the polystyrene it has a disadvantage. So it's very it can actually affect it. You know, when it comes to fire, it can easily spread. So those are one of the disadvantages of polystyrene. But what I'm trying to say is that if you look at this picture, there's a picture I showed you here. Bear in mind that the polystyrene is only taking space. It's not a structural member. So if I remove the polystyrene, this is as if what I we have. Although it may not necessarily be like this, but this polystyrene is only taking space. So even if at the event of fire, even if that means if for example now if the fire is so enormous that all the polystyrene was vanished into the fire, what you will have is like a skeleton of what we are seeing now. So the building will not be affected. So we not have too much effect. Let me not say it will not be affected. We not have too much effect. Because once you have fire on the building, you know, even concrete also they are weak in when it comes to there are degree of fire that concrete can even attain. You know, understand? That's why we have reinforcement inside. You know, so what I'm trying to say now is that there is no much effect in the effect of fire. So because polystyrene is not a structural member, so it's only taking up space. It's only filling up space. Do you hear me, sir?
Yes, I do. Yes, I do. But personally, I would have preferred you making the space, the slab space hollow, removing the polystyrene. It will be better. Since it's not adding to the structural element, we can remove this polystyrene. I've used it before, and that is way back. But what I'm actually particular about is the services aspect of it.
Yeah,
you know, and the question is still standing, and that's about 15 years ago. It's an office space. 4 or 5 suspended floors. Yes, 4 suspended floors plus a paint. I mean, it's an office space, and it's still standing as I speak to you. So it's a technology that is very good, and the building weight is going to be very light, and all that you have just enumerated. But I'm just saying that in the event of fire, will it not be better for us not to have those polystyrenes there? It will be better because it's going to help the concrete slab at the end of the day. So when are we going to talk about the services aspect?
Yes, the services aspect now is what is also achievable on site. You know, if you look at this these drawings, these pictures now, you know, the topping is 75 mm. So and we have space in between the ribs. So in between those ribs, beside the reinforcement, between the rib reinforcement and the polystyrene, you can actually pass your pipes in between them. Sure, you get me? You understand now? So you can actually pass your pipe in between the polystyrene and the reinforcement. Another thing that we actually also do is that under the polystyrene, we can just puncture under the polystyrene and place maybe what you want. You must have placed your pipes before you put this before even the polystyrene and the iron reinforcement. Some small services can be put in place. So once you are installing the polystyrene now, the space for those things will not be, polystyrene is, you can just cut around it and put the polystyrene on top. So there's no, I've never had issue with services on using polystyrene also, because there are space for where you can put them.
I'm aware, why I'm saying that is I'm aware of some structural engineers that will never allow services penetration into the beam. Not to even talk of a construction system that is more like very light, and the rib is about, I don't think the rib is more than 100 mm. Am I correct? Your beam what size is the beam?
The beam is 100. The minimum rib is 100. But you can have 120,
so
you can have 150. So those space can take care of the services.
It can take care of not that. What the point I'm making is not every structural engineer will allow you put pipes in the beam.
No, I'm not
You
saying
get that?
I'm not saying in the beam. I mean beside the polystyrene.
Beside the polystyrene.
Yes, by the side.
Can
Or
I see your cursor? Can I see your cursor? Hello?
hello.
Yes. Let me see what you're talking about.
No, I don't have the picture. I don't think I have. You can see the picture that I sent here. We should actually, after we've casted, we've done this thing before the you can see the pipe on this one of this floor. Although I didn't take pictures when the service was installed. I think I don't have that picture, but it's actually installed before we cast them.
What size of pipe is this?
This is 3 inches pipe.
So if you are having a 3 inches slab, I mean mat on top of the polystyrene, it will be difficult for you to have a 3 inches pipe in between.
No, I mean on top of another thing we do is on top of the, although it might be difficult to put it, but on top of the slab, we can put some services there. Although
okay.
we have
So
challenges.
that makes your slab thicker.
No. No. What happened is that part of the we have a topping of 75 mm. So part of the pipes will be inside the 75 mm. Then we now have some of them will still show above it. So maybe when they are doing the finishes, maybe when they are not doing the finishes inside the rooms, they can now use ties and so to cover it up.
All right. Thank you.
So I don't think I have more time. We have less than 1 minute now. So that will be all for the online lecture. So thank you everybody for coming. Thank you so much.
Thank you.
Yes, sir.
Yes, I will be expecting the recording of the webinar, sir.
Yes. Anson, have you put have you dropped the
Yes, I've dropped the
WhatsApp group
link.
link?
Yes, I've done
Yeah, I
that.
think he has dropped. Yeah, I saw a link on.
Okay, yes, you can join.
Can we have the slide as well?
Yes, I will also drop it there.
All right, thank you.
Yeah, thank you, sir. Thank you, everyone. Thank you for joining. I'm sorry for coming late. I think we have issues with the links. We have 2 links that they are created. So,
hello. Yeah, I'm well.
Yeah, thank you for putting this together. Very informative for non-engineers like me.
Yeah, thank you, sir. Thank you.
You have to pay for coming.
Okay.
Thank you.